In this video, I'll show you guys how to solve a system of differential equations along with these initial conditions. So you know at the end we have to solve for all the constants, right? And also check this out. We have second derivatives. Here we have x double prime is equal to y, and then y double prime is equal to x. This is a very simple looking system of differential equations, but we'll see how this is going to go, alright? Anyways, I'm going to utilize the capital D notation so that I can do this by elimination. And by the way, both x and y are functions of time, okay? Alright, so let's get going right here. X double prime corresponds to d2x, and then we move the y to the other side, so we have this minus y, and this will be equal to 0. And then for this one, let me first move the x to the other side, so we have negative x, and this is going to be plus d2 of y like this, and this is also going to be 0. And now you can pick either you want to get rid of x or y, up to you. But let me get rid of the x right here, okay? For the first one, I have d2 in front of the x. For the second one, I only have negative 1 in front of the x. Let me just multiply by the second equation by d2, like this. And that you will see both of these will have d2, and one is going to be positive, the other one will be negative. So that when I add the equations together, the first term will cancel out for the x, right? So as you can see now, this is going to be d2x and then minus y equal to 0, and d2 times negative x, that will give me negative d2x, and then d2 is going to be d4, so plus d4y like this, and d2 0 is just going to be 0. You technically differentiate 0 twice, you still end up with 0 anyways. And this is wonderful because you see that d2x, negative d2x, they cancel each other out when you add these two equations, right? Right now, I'm combining them together. What does this mean, d4y? This means we have to take the derivative of y 4 times, and we will end up the fourth derivative of y. And let me put this down like this. This represents the fourth derivative y. And then let me write down minus the original y, and then 0 plus 0 is still 0. So this is what we have. How can we solve a fourth order differential equation? Well, we can still change this to its characteristic equation. So this is going to correspond to r to the fourth power, and this is going to correspond to no r, but we do have the minus 1, like this, and make this equal to 0. Factor this, we get r squared minus 1 times r squared plus 1 to be 0. And then let me just say r squared minus 1 is equal to 0, and then r squared plus 1 is equal to 0. I'm doing this way because I know you guys can handle it, and you guys will see this right here is r will be plus minus 1, and from here you get r is equal to plus minus I. Alright? Okay, with all these r values, we will be able to find the general solution for the y. So let me write this down. Y as a function of time. This is going to be, let me write this down first, with r is equal to positive 1. This is going to give me a building block for the solution, e to the 1t, right? And we have to multiply that by a constant, so c1 e to the 1t, which is just t, and we continue the rest. Next we have negative 1 for the r, so plus c2 e to the negative t. And keep in mind, here are just real numbers right here, right? But once you have complex values for the r, you'll end up with sine cosine. And this is r equal to 0 plus minus 1i. Well, we don't have any e to the whatever part because, you know, the real part in here is 0. So e to the 0 times t is just 1. So we don't have e to the whatever part right here. We do have sine cosine part though. Let me first write down plus c3 cosine of beta. Beta is 1 in this case, which is just 1 right here, right? So it's just t, 1t. And then plus c4. And then the next part is going to be sine of beta, which is 1, which is just going to be 1 times t, like that. So anyways, whenever you end up with a complex r, you end up with cosine and sine, but we don't have the e to the whatever power because the real part is 0. This is the general solution for the y. but I cannot box this yet because I still have to find out C1, C2, C3, C4. Anyways, how can we get the x though? Well, the easiest way, in my opinion, is just going to be doing substitution. Let's look back. Okay, let's look back. As you can see, the first equation is x double prime is equal to y, and the second equation is y double prime is equal to x. Your choice. If you're willing to differentiate this twice, you get x already. If you don't want to differentiate this twice, you will have to put this in here so that you can get x double prime is equal to y, which is this, and you have to integrate twice in order to get x, right? I'm going to utilize this. It's easier, right? So let me put this down in blue. From this one, okay, I know x as a function of t. Okay, let me just put on x as a function of t. This is going to be y double prime, isn't it? And let me just put this down right here. Y prime is going to be this one, c1 e to the t. And then I have to differentiate this, right? E to the negative t stays, and then c2 also stays, but then the derivative of negative t is -1, so I have to make this into negative. And then the derivative of this is going to be negative c3 sine of t, and then the derivative of this is going to be plus c4 cosine of t. Okay? However, this is just the first derivative. For the second derivative, I'm just going to put down the result right here, okay? So I can get x of t right here for you guys. For the second derivative, I'm looking at this. The derivative of c1 e to the t is still c1 e to the t. And then the derivative of this. c2 e to the negative t stays. So let me put that down. c2 e to the negative t. But I have to do the chain rule. I have to multiply by the derivative of negative t, which is -1. -1 times this negative becomes positive. And then the derivative of this, negative c3 sine t, is going to give me negative c3 cosine t, right? And the derivative of this is going to be negative c4 sine t, like that. Okay, I end up with a general solution for x, and also have the general solution of y. Well, I'm just going to plug in this values accordingly and then solve for C1, C2, C3, right? But I'm pretty sure I won't have enough space, so let me erase the board. And if you don't want to do this by hand, I will have a video in the description for you guys. I'll show you guys how you can use a scientific calculator or a graphing calculator with matrices to solve this kind of system of equations for you guys. almost done. Just like the marathon, almost done. All right, and the end of the day. This is all good. That's it.